Thanks for coming, everybody. All right, thanks, guys. We appreciate you guys coming, especially we know that we're competing with the lunch hour, so this is an honor that you've made it here today. Thank you. So my name is Nino Weiss. I'm the product manager for Amazon Comprehend. And then today we'll actually be joined by Ben Snively, a solution architect for AWS, as well as Yasser, who runs science for Amazon Comprehend. And we have a special guest, a customer joining us today on stage to talk to you about how they're using the service today. So let's get started here. So, we like to sort of think about positioning Comprehend. We'll talk about what the service is, but this talk really, you should leave this talk with an understanding of how to process all of your data, right? So what I mean by that is we have been traditionally very comfortable processing structured data, so data warehouses, relational database applications, NoSQL type databases, but a lot of this text data has been pretty difficult to get to. And what I mean by that is it required a pretty significant leap in skill set to be able to make sense of this data, right? Traditionally, behind a skill set to get to text data, you would have had to do things like, effectively learn machine learning. You'd have had to specialize in NLP. There's a variety of frameworks out there today, and while they're all making significant progress, it's still not as simple as working with a relational database. And then once you understand the concepts, you have to continuously learn and retrain models. And this in itself is a task, it's a feat. And that's something in Comprehend that we're removing for you. And then finally, after all of this, you can start to use this text data, this unstructured data that we like to talk about it. So the way that we'd like for you to think about this talk, think about using this service, Ben's going to come up and he's going to show you really nice code level demos that you can then take and go apply. We'll make sure all that code's available to you. But think about Amazon Comprehend as almost being like a machine learning based data connector to unstructured data. It's sort of how you think about it. But we're really going to focus on, we're not going to dive deep on the machine learning part. We're going to dive deep on the use cases and how you use the technology. So the service itself, we like to say it's fully managed and continuously trained. So what this isn't is a library that we just sort of host for you. What it is a service that is backed by a full-time engineering and full-time science team that thinks deeply about text analytics nonstop. So we think about what is the state-of-the-art algorithm approaches? What are the state-of-the-art algorithms that we can use for text analytics? How do we continuously think deeply around collecting more data to continuously make sure the service becomes more accurate over time? Right? And if you're a customer, we don't use your data. If you want to share your data with us, you can. Otherwise, you can simply opt out. We have a full-time team that goes and collects data on your behalf. We implement things like transfer learning so that when, I'll talk about custom Comprehend later, we provide the data, we provide the science expertise, and we actually take care of the training for you. So this service really removes all of that. And then, of course, we make it available to you with the availability of typical AWS services. The service itself, here's a quick functional overview. The service itself has a number of APIs. So the first API is the entity API. So that API extracts, and again, we'll go through code level details, show you guys what these look like. But that API extracts, think of it as proper nouns, as typed proper nouns. So what I mean by that is we'll extract people, and we'll have an entity type called person. We'll extract organizations. We'll extract events. We'll extract locations and time. So a lot of our customers have been using this to do things like, I'm going to go through and deeply find out what's in this document, what's contained in this document. We have a key phrase API. The key phrase API is typically used in conjunction with the entity API. The key phrase API really does common nouns, right, and common noun phrases. So using these two APIs together, you're getting a really nice understanding of what's actually in the document. We identify language. So the service itself will identify up to 100 different languages, right? So if you're doing business with a multiple set of markets, or you need to understand what a language is before you maybe go translate it or have another business process workflow, we'll identify the language for you. The service identifies sentiment. So sentiment's very popular in applications like understanding what your customers are saying, maybe understanding the experience that they're having. Are they neutral? Are they negative? Are they positive on something? So a lot of our customers want to know, hey, what was being said in the call center conversations yesterday? Maybe they were using Amazon Transcribe to transcribe the calls. And then they want to go through and analyze those calls and say, you know what? let me just, this is the glass half full thought process, but let me go through and find out what were all the negative comments that our customers had yesterday. And then now that I've identified those, let me go use some of the other APIs and let me go find out specifically what did they say. What brand did they mention? What product of ours did they mention? What were the descriptive words they used, right? So this is sort of how you think about using these APIs together to fully understand text. We've introduced the Syntax API, which is a lower level API that helps you parse word boundaries, grammatically correct word boundaries, and applies a part of speech. So you'll know if something's a noun or an adjective, for example. So again, as you build on these APIs together, you can really go down to the lowest level granularity of understanding what's in that text. We have another API that helps you organize documents, right? So it's topic modeling, and this effectively helps you group documents based on similar keywords. So we'll have customers come in and say, look, we just got a dump of documents yesterday from some business workflow. There's 2,000 of them. We don't really understand what's in them. You can take topic modeling, point it at that corpus of documents. They'd be stored in an S3 bucket. And then the service will organize the documents based on however many topics or groups you've asked it to do. What that does is it looks at the actual words themselves and does a statistical grouping of those like words so that you could see, okay, yesterday we had 1,000 documents come in, and now if I organize them, these like words are showing me the categories. So you could say, these things really look like customer complaints. These things really look like product orders. So it's a nice, fast way to analyze or organize documents. One of the biggest things that we just announced, actually on November 15th and 16th respectively, is custom Amazon Comprehend. This is actually quite a big step forward for Comprehend. So as I was talking about, is the service initially went to market actually last year at reInvent, and we had something we called pre-trained models. So what that meant was the service would train our entity models to go look for things like people, organizations, locations, events. Now, what if your business has entities you care about that aren't necessarily popular entities that everybody cares about? Well, what we found was our customers loved the pre-trained models, but then they wanted the ability to customize the service to do their own entity types. So I'll show you an example, things like policy number, or things like a make or model that's specific to your company. The problem was, if you remember that first slide I showed you, then you'd have to go all the way back to the drawing board, learn machine learning, prepare and annotate data, train a model, deploy the model. So the team took on the challenge of saying, let's actually remove all of those steps on behalf of our customers. Let's make customization of NLP as easy as it is to use Comprehend today, and then we'll talk about what that means. The first feature we introduced in Custom Comprehend is custom classification. So in NLP, a classifier is simply something that looks at a document and applies a label. It's categorization of documents. And so the way that you train a classifier, so it's really good for doing things like automatically triage support tickets. I mean, how many of us, I know at Amazon we do this, I'll look at a ticket and I'm like, I've seen that one before, and I do the drop down and I assign a label. So now you can imagine that those routine tickets can get automatically triaged, right? You can moderate forums. So we have customers training classification models to go through their customer forums to do things like, are these guys, is there bullying going on? Is there explicit, is there profanity? Are they mentioning our products or brands maybe in a negative way? So you can train these classifiers to do a multiple set of things. And then so, for example, for the pictures, your documents will come in, the classifier will run, and for each document, it'll append a label, and then your business workflow can start doing what it needs to do with those documents. Now here's the neat IP. How many folks in the room have actually trained a classifier before? Okay, great. As you know, we know, it's not very easy, right? There's some knowledge required. You've probably built up quite a bit of knowledge. You'd have to do things like select the right algorithm. One algorithm for short text data could be different than another classifier algorithm for longer form data. So there's a lot of things you have to learn to build a highly effective classifier. So what we've done is we've effectively built an automated way to train these classifier models for you. And Yasser's going to come up and talk a little bit about how we've done this. But what's amazing is all you need to do now is if you can build a CSV file, you can train a classifier. So this is literally the schema that you'll have to provide. You'll provide us the text itself for each category, and then you'll provide the label that you want for that category. So you could open up your favorite spreadsheet software, go get a bunch of examples, label those examples. You might have a business analyst at your company do this work now. And then you can save that file and then submit it to the service. And then the service will automatically look at the data. It will select the right algorithm based on the data set that is the most optimal. It will actually automatically tune and test the model. So it will take some of that data you provided and set it aside and build a test set. And then you can do all of this today through our WYSIWYG console. You can open a console and write 0 code to train the classifier just by simply pointing at your CSV file and then explaining to us where you'd like the documents emitted. Or you can fully do this through the SDK through APIs and automate the training and the consumption of classifiers. Custom entities is the second key custom feature we've released. So custom entities, if you look at the example on the board, things in red, and actually, so for folks, the things at the top, the 2 entities at the top, are entities that Comprehend does today. So person and organization. The entities on the far right, part number, and the entities on the bottom left, account action, are in yellow. Those are entities that were custom. So we wanted to show you that now what you can do as your business is you can use our pre-trained entities, go train your own entity model, and then get a full superset of all the entities that are key to your business. The same thing applies in terms of ease of use and automated training for custom entities. So we've removed all the complex steps involved here. How many folks in the room, again, this is so fun to ask, how many folks have trained a custom entity model? Okay, so this hurdle is even bigger than the classification one. And so what we've done is we've reduced this set of steps. You require no machine learning. We've reduced the set of steps down to 2 things. You need to prepare the entity examples. So for example, let's say we want to create an entity type for parts. It's maybe our unique part codes for our company. Go get those entity types, put them in a CSV file. Put them in a single column, give the column a header, which is your type name. The second thing we want you to do is point us to about 1,000 documents that contain your part numbers in the context of how your business uses them. So of course, we all probably have documents laying around that contain things that are important to us, like part numbers. So you just want to go collect those and put those in an S3 bucket. What the service does is it synthetically annotates the data. So this is a key step in training machine learning models. We'll take those entity examples you gave us. We'll go look at the actual documents that you've given us that contain those entities in example, and we'll prepare the data set for you. So this way, what you're getting is a machine learning model that's contextual to your business. For example, you can imagine that the word chip is different to an insurance company than it is to Frito-Lay. And this is the deep neural accuracy that you're training by providing us the sample data. And again, similar to classification, the service will automatically annotate the data. It will select the right algorithm amongst a few different algorithm choices that our team continuously monitors and changes and updates. And then we'll tune test, and you can, again, do all of this through the console with no code, or you can also use the SDK and the APIs to automate all of this for you. One of the other things that I like to show is when we're doing kind of a short customer conversation, a face-to-face, we always tend to draw this picture. And I think this picture is really helpful if you're new to NLP and you really want to understand what the service is doing. In this case, we all like to think, at least I know a lot of us do, think about data in a structured way. So this is an example of what Comprehend's doing for you, for example. On the left-hand side, you can see the column headers, which is person, organization, or location. And you can see that the service itself is extracting those actual variables. We're taking out all the people and all the locations being mentioned. And then the 2 columns on the right are custom entities. Those are the 2 entities I just added. So now you can imagine I'm building a really complete superset structured view of my data. This, what created this table was actually Comprehend going through unstructured documents and extracting these words, these terms, and these short phrases, and allowing you to compile this data in a structured way so you can do things like join, sort, filter, provide search predicates, which Ben's going to show you code level detail. So we like to show this. This is effectively what structured output looks like. So what I'm going to do at this point, let me please invite Yasser up to the stage. Yasser is our science lead for Comprehend. He leads the team of scientists that are thinking all the time about how the service can improve, how it can improve accuracy, and what new state-of-the-art approach could we bring into the service to make it better for customers. So Yasser?
Hello. Hi. Good afternoon. My name is Yasser Alonaizan. I'm the science manager for Comprehend. And the mission of my team is to abstract away the complexity, the ML, NLP complexity, and make the latest and greatest advances available to you as a user of Comprehend. So the mission of the team is wading through all the scientific advances that happen in deep learning and machine learning and so on and so forth, and making sure that we make that available without you having to know about the technical details that go beyond just using the service. So we started first with the algorithms that are needed for pre-trained models, and for that, we do the training and we do the optimization and so on and so forth. And then now we're advancing into making these custom models that you can actually bring in your data. So now we have to worry about making all the optimizations that happen available to you as well, so that you don't have to worry about optimizing this for. So basically, the mission of the team is, wading through all the different state-of-the-art algorithms, and the secret is that there is no one-size-fits-all. Certain algorithms are suitable for certain tasks and data sets and so on and so forth. So instead of you worrying you having to worry about that, we worry about it and we do it under the hood, so you don't have to. And it's ready to use. You bring in your data if you're using custom, or you can just use the pre-trained models and do that. The algorithm selection, for example, this is something that we do under the hood, so you don't have to worry about. Do I use this, PyTorch, or do I use TensorFlow? Do I use MXNet? Do I use this particular architecture or that architecture, and so on and so forth? I was going to show a slide of a neural net architecture, but Nino vetoed that, so so I'm staying with these 4 bullets. So anyway, so we do all of that, choosing the appropriate algorithm, doing the tuning of the model and so on, whether that's for the pre-trained models or also for the custom models that you train with your own data. So we do the tuning and the testing and finding the appropriate algorithm for that particular set, for that particular task, and we make it available to you. And then we also manage the deployment of the models and managing the usage of that after. So that's all I have.
Thank you. Thanks so much. Oh, that's great. That's great. So one of the things that the Comprehend team is, it's actually like all AWS teams, we're very customer obsessed. We've been very fortunate to have some really great early customers that are helping us driving feedback, and these are large text analytics customers. So they're really beating up the service. They're giving us great feedback. We're getting better and better every day. So we're very fortunate. Today, what we wanted to do is take a chance to let you hear directly from some of those customers, in particular today, FINRA. So FINRA has been a great customer, a great early partner, and it's Matt and Demetrio from FINRA, and we're excited to have them. So Matt, would you like to come up? Thanks.
Am I on? Is the mic on? Yeah, there we go. Thanks, Nina. I'm Matt Cardillo, and I'm a senior director at FINRA. I've been there for 11 years, and I was one of the senior managers responsible for the moving to the public cloud that kicked off in 2014, specifically around self-service analytics and complex market reconstructions, so user-facing applications. Dmitro Delgopolov, we've been working together the entire time I've been here, and he is kind of our beachhead. He understands content and unstructured data, and he's our beachhead for text analytics at FINRA. So let's get into it. So about 5 years ago, the high watermark that you see on screen here it's about half of what it is today. The 135 billion records that we took in was just this past October. So it's pretty staggering how these numbers just keep changing. We bring in a massive amount of data. So for those of you who don't know us, we are FINRA, the Financial Regulatory Authority. We regulate nearly the entire equities market and the majority of the options markets. Our mission is to provide market integrity by ensuring that the markets are fair and orderly so that investors are protected and essentially people feel safe investing their hard-earned dollars in the marketplace. So as I said, we have a massive amounts of data. We perform complex reconstructions on this to make sense of these market events that are coming in and flooding into the company every day. In the past 5 years, we developed a core competency around structured data and managing that structured data in the cloud. So namely, as an organization, we don't think of our infrastructure as fixed any longer. We also developed robust data management solutions, which we've also open sourced. We've employed innovative partitioning strategies. And this is really to account for the fact that our data is very highly skewed. And we don't know what questions people are going to ask of the data. We also employ multiple query engines based on different usage scenarios so that we're using the right tool for the right purpose. So if it's a user waiting at a laptop, they're getting their answer back very quickly versus one of our surveillance programs that's combing through data looking for nefarious behavior. So we've done a lot around structured data. So what's next? And I would say our challenge is really, so FINRA has a very large backlog of casework that we refer to as matters. And working on these matters, there's lots of unstructured content coming in. And this includes things like there it is. Form filings, documents. We get nearly 1 million documents a year. Email correspondence, and also reference data, or data that we use as reference as part of our analysis. So unearthing key features like the who, the what, the where, the when, how is very time-consuming. It's very error-prone, and sometimes downright painful for our regulators. Some of our more complex cases have thousands of files associated. So having to go through these things manually, how do our analysts really know with high confidence, a high degree of confidence that they haven't missed something? So here's a simple example of information that comes into FINRA. So that top paragraph, that's the information that we receive. So we've got essentially an investor, John Doe, that invested in some annuities that were sold to him by William Smith, but he's claiming he didn't understand these investments. So that's the kind of stuff we receive. The kind of stuff we need is essentially that the investor's John Doe, the broker is William Smith, and what his unique identifier is. And this is where Comprehend comes into play. So we're building text analytics solutions using key features of Comprehend, such as entity recognition and the text classifier to help us basically unearth these features important to the regulators to sift this out of the pile of content that we're constantly bringing in through filings, through information requests, through tips, and so on. But we want to go further. And we'll be considering Comprehend's custom capabilities that Ninu spoke of today, so that we can get get more complicated in terms of the things that we're going to unearth that are terms more specific to our business of regulation. So that's what we're working on. And the capability that we're building, we call it the Comex Command Center of people and organizations. Sorry, let me say that again. The Comex Command Center of People and Organizations. So an organization like FINRA, we're oversighted by the government. So true to form, like any organization that has governmental oversight, we've gotten really good at naming capabilities that just roll right off the tongue. Could you tell? But they always seem to very conveniently fit into an acronym. So all kidding aside, I'm going to invite Dimitro up to talk about C3PO and what we're doing to make that a reality at FINRA. Dimitro?
Thank you, Matt.
Thanks, man.
Hello, everyone. My name is Dmitry Dolgopolov. I'm a senior director at FINRA in charge of document management. And obviously, what's document management without text analytics. So let's talk about what we've built with our C3PO. What you see on screen right now is actually a real application. Names almost real. If you squint, you may even recognize some of them. But that's actually a real document that comes into our system, and it's a 200-page document, this particular one. And this application you see on the screen allows our users to sift through that huge document in a matter of minutes and not days, okay, maybe hours, and being able to identify the key information in this document. And as regulators, what we are looking for, our key pieces of information, things like, we call it bad actors. And bad actors are people with some known regulatory history, with some known problems from the past, or some people who are not following all the rules of compliance. So this particular application allows our users, with the help of Comprehend, of course, get to the most important pieces right away. You can see users can identify now there are 3 bad actors in that particular document. And why is it important? It means they need to spend more time analyzing and reviewing this document. And if there is another submission, another document, or another set of documents that all clean as a whistle, then they can spend less time and focus on the risk-based approach. This is our very, very high-level architecture. It's not even 10,000 views, I don't know, stratosphere. As you can see, we've built some modules around Comprehend and how we can leverage Comprehend for text analytics. So in this particular case, you need to prepare your data before you can feed it to Comprehend. And as Nina pointed out, it takes some time, but Comprehend makes it easier. However, you still need to spend some time. Let's not fool ourselves. You need to spend some time, prepare data, and because as a self-regulatory organization, we actually try to make it simple to our firms to be compliant. And we actually redefine the whole meaning of unstructured data. It's super unstructured, so it's freestyle almost. That makes it a bit easier for our firms, but obviously makes it more complicated for our reviewers. So that's why we leverage a lot of AWS services. We use step functions, and that's where it starts from. And then we have modules that do data preparation, some cleanup, OCR sometimes. Then we feed it to Comprehend. We have our own modules to do entity matching, which I will talk about in details later. And that allows us to do, sorry, Nina, very, very cool stuff. So it's not that Comprehend is not cool, it's cool, but you see on the right side, you have Amazon Neptune, Elasticsearch, and actually this is where we ran out of space. There are so many other things that Comprehend enables us to do. We can build like now better models for machine learning. We can feed this information to SageMaker. We can make our enterprise search to provide more precise information, better results, better quality results. So, the way I see it, it's if you want to have dessert, you need to eat your vegetables. So that purple broccoli in the middle, very important part of our diet. So let's now look under the hood. And let's see how exactly we implemented the entity matching that we are bragging so much about. So it all starts with, you have a pile of documents, and you prepare it, and then you unleash Comprehend on it. So as a result, it brings back how we call it feature sets. What is a feature set? It's essentially information about individuals. So we use some semi-proprietary techniques such as proximity, context, nature of a document, in order to combine together all the information about a single individual. So you see on the screen that a feature set typically consists of things like name, email, address, employment history. So Comprehend allows us to bring all of that information, and we use our tricks to combine it all together. Now, what it gives us, it's actually unbelievable. So our database of registered individuals that we need to match or identify is pretty large. I mean, we're talking about a few million records. And about 600,000 of them are actually actively participating in the market activities individuals. So you can imagine that going through one-on-one, even through using technology is impossible, not to mention doing it manually like our investigators had to do it in the past. And we use some full text search techniques to narrow down the set. And this is, you see, where we move to the right to the comparator area. Now it's not 2 million that or 3 million that we need to compare with. It's now manageable subset. So we've built additional comparators using machine learning, where we now can quickly go through all of the dozens of candidates for matching. And after that, it brings back typically handful, I mean, for very, very common names like William Smith, our favorite guy Matt talked about. It's very manageable. In addition to that, we provide to our investigators, to our users, a very good view of this is a high confidence match, this is a low confidence match. And now they can just focus on a very, very narrow set, very important individuals. And we'll flag them for them, saying, hey, you want to look at this guy more carefully than the other two. So benefits. What do we get by eating our vegetables? So benefits are all over the place. I mean, there are benefits to technology. There are benefits to our customers. As technologists, what we benefit from, we can extract individuals and organizations. OK, good. We can now match them, as I explained, to entities, those entities to FINRA records. We can flag individuals. So out of all William Smiths, maybe only one of them is required special attention. So you can skip the other 3,000. And it also enables us to do higher level analytics, like machine learning, like community detection. You saw that Neptune reference on the previous slide. That's what we get by using Comprehend. Now, benefits to our customers, our investigators, our reviewers. So we bring information to them so they don't have to mine it manually. So in the past, when the investigator receives a 200-page or 800-page document, which is not unheard of, they have to manually highlight. They use a lot of highlighters, run out of them very quickly, and then manually search for those names in our internal systems. It takes time, as you can imagine, and it's very error-prone. Now they can just look on the screen and see what we get. We can flag individuals, so they don't have to do it themselves. And that, as a result, it reclaims hours of tedious, error-prone work, and allow our users to focus on strategic efforts instead. Net result: regulatory reviews made easier. Thank you, everyone.
Oh, that's awesome. Yeah, we really enjoy working with FINRA, and we really appreciate it. When one of the world's leading financial analytics companies comes to you and says they want to work with you to analyze tax, we're so appreciative, and we don't take that opportunity lightly. So we're really excited to work with FINRA and continue working with you guys. So thank you, Matt and Dmitrio. So let's get into architecture patterns. We'll do this quickly, and then Ben's going to come up and show you guys some code level stuff, just so you can see. But real quick, one thing Dmitrio said, and it really stood out for me yesterday. We were going through his slides. He said, he gave you a little preview up there. He said, I don't want you to be offended, but Comprehend is just a little piece of this. We're really excited just to kind of go in and analyze the data. And I was telling him, I think that's a huge compliment. That's actually what we're trying to do. We're actually trying to remove anything related to machine learning or any complex set of work or set of skills that you have to learn to go build graph databases or to go build better search solutions, right? So we're very honored to get that feedback. So real quick, for those of you new to kind of NLP and you're starting your NLP journey, and we know there's a number of you in the audience today, we wanted to show you a couple of the top use cases. And I know it's a very verbose slide, but we're going to make these available after the talk. But let me call out a couple of these really quick. We'll have Ben come up here. One of the biggest things we see is semantic search. And he's going to show you that today. What that means is with Comprehend, you can do things like boost and rank search solutions for better accuracy. So you can, when you're indexing your documents, you can run them through Comprehend to do things like extract the entities, extract key phrases, and store that as metadata. You can even extract the sentiment on documents, and Ben will show you how to do this, and filter on sentiment. So it gives you really rich search solutions. We see customers doing things like saying, hey, we've got a lot of unstructured text either in our data lake or in our data warehouse, or a modern data warehouse really covers both. And we actually love the fact that we can structurize that text to go do joins, filters, and sorting. Right? So when you're thinking about how to apply NLP, think about how do you join or augment or make your unstructured text analytics better by now leveraging the unstructured text and bringing it into that environment. Another thing we see, which is of course a really popular use case for NLP, is social analytics. So we have customers saying, I want to know what my customers are saying. I want to know what's going on in my call center conversations. We've got a really nice solution with Transcribe. You should go search for that content. But they want to understand, what are people saying on Twitter? What are they saying in our forums? So we see a lot of these kinds of use cases applied, in addition to the enterprise-grade use cases around financial analysis. Tomorrow we'll talk about, we have a big customer in legal analytics as well. One of the other slides we find that helps a lot of customers start their NLP journey, and I'll pass it to you, Ben, next, is really how does Comprehend fit in? Again, it's like a machine learning NLP data adapter. So it takes your unstructured text, gives your text structure, and then allows you to go into any analytics service you want and work with that text. So you can use Kinesis to do near real-time understanding of maybe tweets are coming in. You want to know what's trending up or what's trending down in terms of negative or positive sentiment. You can work with Elasticsearch, as I said, to build smarter search domains, better search. You could use things like Redshift and Aurora, right, to take that unstructured text, structurize it, and do things like sorting. And of course, if you're invested in the Hadoop platform and EMR, you can go take the structurized text from Comprehend and go do larger scale analytics things in EMR as well. So just think of it as sort of it sits between unstructured text and structured analytics services or semi-structured analytics services, and it really removes any knowledge of machine learning that you previously would have had to learn to do this. All right, so Ben, why don't you go ahead and come on up, and we'll talk about Graph. Thanks, man.
Thanks. All right, so we're actually going to switch over to some demonstrations now. Thanks. And in doing so, first wanted to set the stage really quickly. The first thing that we're going to show here is how you could use Comprehend in conjunction with a graph database, Neptune. How many folks in the room are familiar with Neptune? OK, a pretty good amount. So Neptune is our graph database that lets you store both property graphs as well as RDF graphs. It's really great to be able to do very, very rich querying over various types of languages like Gremlin or Sparkle. And what we're going to be showing here is we're going to be showing how you take news article feeds. So we went ahead and we grabbed RSS feeds that we're downloading into S3. And then we're going to be processing those using Lambda and then storing those in a graph database, a named entity graph. And then we're going to start querying some of those. The second one we're going to show is actually how to also do this with Elasticsearch and enrich your search capabilities with semantic technologies, with really the NLP capability. So let's go ahead and switch over to show the demo here. The first thing I'm going to show is what this data looks like. And I promise I'll zoom in here as well. Let me double check the Wi-Fi connection really quickly. So what we're showing over here is I'm going to show you some of the data we're ingesting. So this is news article data. We're using S3 Select to actually look at this data. And what we're doing is we're actually bringing this into Neptune. And let me make this quite a bit bigger for folks in the back. So this is just bringing in a property graph. And if we take a look at this data, it's news articles from our blogs. So we're taking RSS feeds. We're ingesting them into S3. You're using S3 Lambda notifications to be able to ingest them into Neptune. And if we go ahead and bring up Neptune now, what we're going to show is we're going to show how you can start querying this data. So we're going to go over here, make this bigger for everybody. So I'm actually just logged into an instance, and I'm actually going to bring up a Gremlin interface. This is open source technology, Apache Gremlin. But since I'm running Neptune, I don't have to worry about any of the management of the graph database, anything like that. I could start doing my queries right away. And what we're going to do here is we're actually going to start doing some queries, some graph queries against this news data that we've ingested into here. So the first query I'm going to do is I'm actually going to just query for I'll actually skip to a eigenvector. So this is actually going to query for the most influential entities in our system. And what you'll notice, and let me make this a little bit bigger, is these are all entities that got extracted using comprehend. And I can show some of the code here in a minute, but using comprehend is just a very simple API. I call detect entities, it pulls those entities out, it pulls the types of those entities out, and now we have all these different entities. And you see AWS and Amazon, not too surprising since this is from blog posts. Some of the top entities talked about the most influential entities, and then you can see various entities listed here as well. But what I could also do is I could actually start visualizing a lot of this data. So if I actually want to start looking at this graph data, what I could do is I could bring up, I happen to be using an open source project to visualize this graph. But you could, we have lots of partners that integrate with Neptune to be able to visualize graph data, which is being enriched all through the entity extraction here. But what I could do here is I could actually do things like search for MySQL for the name, hit search. So this is actually an entity that got extracted from blog posts referring to MySQL. And I guess look over here. I don't know what happened to that projector over there. What we could also do here is, since these are all the different types, you can see, persons, events, organizations. Those are all the different types pulled out of entity extraction. What we could do here is we could also start browsing this. So if I wanted to take a look at the different names here, I could start looking at these are all the different articles that are talking about the entity MySQL. But I can start browsing this graph and start expanding this out more and more. So the other thing that we could do here is we could also visualize this data so that the color coding on the knowledge graph or the graph here indicates what are the different types of entities being used. In more time, and feel free to ping me after this, I could show how you can start doing some really, really rich querying over the graph database here. So you could actually do very, very complex recursion over the different nodes and edges on this. So some really, really powerful to be able to query this data. But in the interest of time, I do want to show the Elasticsearch piece. So on the Elasticsearch piece, we're actually doing a little bit more in terms of extracting data. So what we're going to show here is taking the same news articles, running it through comprehend and extracting not only entities, but those key phrases, the sentiment, and also syntax. So you can see some of the syntax fields of these articles coming in. And we're storing that into Elasticsearch, and we're going to bring up some Cabana dashboards to be able to visualize the data. So this is the Elasticsearch cluster that we have running. And if I look over here, I can actually see under my indexes, these are the articles that we're going to be showing. There's 47,000, something like that. Pretty small when it comes to cluster size that you can have in Elasticsearch, but it's not like a little 10 record hello world type thing here. But if we actually go ahead and go back over here, I'm going to dive into some of the Cabana. So let's bring up Cabana. Cabana is a nice dashboard or a nice UI that you can put on top of Elasticsearch to be able to query all types of information. You can build visualizations. You can build dashboards. It's a really nice tool to be able to start searching that textual analytics. So what we're going to do here is we can actually go over to Discover. And in the last 15 minutes, we haven't had any new posts ingested. But if I take a look at year to date here, we can also see all the different articles flowing in here. The nice thing here is combining the leucine-based indexing with the NLP lets me do some kind of advanced querying here now. So what I could do is I could go ahead and search for things like SageMaker. I typed that correctly. And we see 19 of these posts have to do with SageMaker. What we could do is we could actually take a look at this content. And what we see is we actually see both the raw data as well as this was a post from Dr. Matt Wood here. We could also see all the different types for these entities. So the organizations, the commercial items, as well as various confidence scores. So here you actually see a score value. The nice thing about this here is what you could do is these are actually 19 hits that just got returned. I could start applying confidence intervals on my searches here, or do things like query boosting and other advanced querying. So let's go ahead and do that next. All in 2 minutes, I promise. So what we're going to do here is I want to show you first how you wouldn't necessarily do this, because this is a common thing I see customers try to do, and it's actually not doing exactly what they think is happening. And then I'll show you the right way of doing it. So what I just queried here is I actually just queried SageMaker with a confidence score greater than 0.99. But what I did is, since in Elasticsearch, I actually have an element in here that's not nested. What that means is it's actually matching any entity that has, or any documents, any article that has SageMaker in it, and then any document that has any entity that has a 0.99. It's not keeping that correlation in this example. In order to keep that correlation in Elasticsearch, what you want to do is you want to create that nested element underneath and be able to query that nested element, which we're going to do next. So if we actually, just to show some of the querying here, if we actually go into here, this is what applications would be querying. And if I query this just with SageMaker, we see 14 documents getting returned. If we actually go down here and now query the same sort of thing that we did before, and say within this nested element called entities, we want to keep in the same nested fields now and search for the 0.99 and SageMaker. If I actually now execute this query, you'll see it only actually returned the five documents that were related to it. So really, really powerful. What you want to be cognizant of is how the reverse indexing actually collapses nested elements when you're setting this up just as a pattern. But if you actually set it up this way, you could query any of these fields within here. Just to show another example really quickly, this is a last query that we have that is actually querying the parts of speech. And in this example, we're actually querying for the word build, where it's a verb, and it's at a score of 0.999. So this is actually showing some of the parts of speech capabilities. I could really be querying for all types of different things rather than just, build is usually a verb. So not probably the greatest example there. But what you can see is you can actually see the various returned elements, the various entities. And then down here, you'll notice all the different parts of speech down here with the various scores related to it. So the punctuations, the nouns, the pronouns, that sort of thing. So very, very quick demos of how you can start integrating some of these things together. And I think that's a, yep.
So yeah, it shows you that you can now approach text analytics with zero knowledge of machine learning using Comprehend. And we want to use a couple of these use cases. If you go to our blog, we link to a bunch of formation templates that were fully deployable solutions you can go ahead and try out on your own by changing the data source connectivity. I know we got to run, so we really appreciate it, everybody, and thanks so much for your time. Appreciate it.